This video presents an autonomous robot packing system that can pack a large variety of objects into containers. Packing is the last step in fulfillment centers before order is shipped to the customer. And human packers often don't select optimal boxes because they're under severe time pressure. Our robot can optimize the packing strategy and even select the smallest box for a given order. The system consists of 3 overhead depth sensors and a robot arm. The highlighted orange area is the picking area where objects are picked from, and the highlighted green area is the store area where objects are packed into a shipping box. Given a set of items, the robot first uses depth sensors to scan and estimate the 3D shapes of the objects. Our planning algorithm then chooses where the object will be placed and in what order, and it automatically selects a box of the right size. Once the selected container is located in the packing area, the robot starts packing. You can see 2 views in this video, one from overhead and another from an in-hand camera. The robot picks up the objects using a vacuum gripper and loads them carefully in their planned locations. Our planning algorithm ensures that the object and robot will not collide with the container wall and other objects already placed. While the object is being packed, it also ensures that the object will be stable after the robot drops it, so that the object does not fall over and ruin the plan. In most cases, the packing goes exactly according to plan, and the robot loads the item exactly as it is intended. However, in some cases, the packing doesn't go as planned, and our system can catch many of these mistakes and recover from them. Before we explain this in detail, in this experiment, I used my hand to push a placed object manually to simulate such disturbance. The robot scans the container and figures out what to do. If the object sticks up outside the container, as it does here, the robot decides how to best push it back in. Now let's discuss a bit on what causes these mistakes. Remember that each object hasn't been seen before, so the robot may not know the object's mass distribution or whether it deforms, or how it might shift while it's being picked up. This may all result in an object to rest in the wrong location after placement. By scanning the container, our robot system can detect whether the previous plan has been violated and replan accordingly. At this point in this video, the master bottle is pushed to the other side of the container. Now the robot will need to replan the box of nut crunch it is holding, and it decides to place it directly on top of the cracker box. We will again be abusing the robot by sliding the box of nut crunch to the side. We will be fast-forwarding the rest of the plan, where we push around the remaining items, the socks and 2 sugar boxes, and the system adjusts and replans for all of them. You can see that despite this abuse, the system still manages to find a placement for each of the remaining objects, and all items fit within the container when packing is complete.